GNSS performance, and one of the reasons that the performance is so good is because the Russian satellites have a signal that is literally 4 times stronger than the signal coming from our satellites, which gives it the ability to punch through tree canopy so much more effectively. So that's one of the reasons that we can go out in heavy timber and still pick up 7 or 8 satellites. It's got a completely integrated data capture solution. In this case, it does have a built-in camera, so you can add photographs to the features that you're currently collecting. And it's obviously optimized for mapping and GIS applications because it runs TerraSync, ArcPad, ArcGIS Mobile, and another wide variety of mobile software. So the centimeter edition, a lot of people have been asking for higher accuracy than sub-foot for GIS, and it's really interesting because you used to have to buy a very expensive RTK system where the rover would be costing you around $28,000, and today you can get a 1 centimeter mapping system for about $16,000 or $17,000. And the reason it's so much less expensive is simply because a surveyor is purchasing a lot more sophisticated software that the mapping and GIS industry simply does not need. And an example of that sophisticated software is the ability to do least squares adjustment, where you're setting up a survey control network and you need to hold certain points as control and allow the adjustments to go into other points. Another example of that is that with survey software in the data collector, you can actually do a site calibration. That's also something that is not possible with a mapping system. So that's one reason that we can still achieve this incredible accuracy of 1 centimeter, but we don't really have the supporting survey software that a surveyor would typically need. So to do this, you have to have a centimeter edition of TerraSync. You also have to have the latest version of Pathfinder Office, and you don't have to post-process your data if you can pick up real-time corrections from a virtual reference station or from a single base. You can get this centimeter level of accuracy in real time. If you're doing that and you're using a single base, you have a very limited distance that you can be from that base in order to maintain that centimeter accuracy. But a VRS, which is a virtual reference station, means that you're inside a physical network of a lot of base stations. And you'll find that there's about 10 or 15 states in the country that has that feature. And this is also optimized for mapping and GIS simply because you're using a data dictionary. If you're using ArcGIS or ArcGIS Mobile, unfortunately, those programs do not support the centimeter level. So one of the reasons that Trimble is sort of promoting this new concept is that TerraSync is the only field data collection software between Trimble and Esri that has the ability to provide highly accurate 3-dimensional data. And what I mean by that is even if ArcPad and ArcGIS Mobile supported the centimeter level accuracy, you would not be able to get good vertical accuracy. So for that reason, only the centimeter edition of TerraSync will support this functionality or this accuracy. You can purchase this a couple of ways. You can just outright purchase the centimeter edition bundle. And of course, this includes the Geo XH6000 with the centimeter option enabled. It includes a license of TerraSync. It includes all the products that you see there on the slide. And the only thing that you actually have to purchase if you don't already have one would be a range pole. And you can see how the pole is configured with the Geo XH and the external antenna. So this edition bundle actually includes everything you need other than a range pole. Oh, one more thing. You also have to have the latest version of Pathfinder Office. So if you have a Geo XH6000, then you likely already have the latest version of Pathfinder, but you do have to procure that as well. So here's our first polling question. I'll put this up on the screen in just a moment. This first question says, do you use an external antenna to collect data with your GNSS unit? So let me launch that slide just for a second. It should be appearing on your screen in a few moments. So just take a few moments and make a selection there. Looks like we have about 80%, 90% voting so far. Okay, so let me close this and I'll share this with you so you can see the results. Looks like about 44% say yes, they do use an external antenna. That means you're probably either trying to achieve better accuracy or you're working in some obstructed areas, which is pretty common. At least about 39–40% of you do not, and a few percent of you do rarely. So the reason we ask this question is because it's sort of important. If you decide to move into a centimeter addition option from an existing GeoXH, or if you decide to purchase this thing outright, you do have to really cope with the idea that you'll be using a range pole and you'll be using an external antenna. It's really not possible to get that same high level of accuracy with the built-in antenna, so the external antenna is really required. So this upgrade option, here's an idea that if you already have a GeoXH 6000, which is the unit that you can upgrade to the centimeter directly from, then you need to upgrade your license of TerraSync. And of course, Trimble does provide an upgrade path to go from TerraSync Professional to the TerraSync Centimeter Edition. It does require the latest version of Pathfinder Office, and for those of you who are keeping your licenses current, you likely have that version anyway. You do have to add the centimeter output option, and literally that option is built into your GeoXH already. So you would get a code then, which would then activate the ability of that receiver to produce 1 centimeter. You do have to have the Zephyr Model 2 antenna, which is a very accurate survey grade antenna. It does pick up L1 and L2 on GPS, and those are the 2 frequencies that our satellites broadcast. It also picks up G1 and G2 on the GLONASS satellites, which are, of course, the Russian constellation. And then, of course, you need those accessories, like the range pole, the bracket, and so forth. So we can provide you with all the information that you might need to go this direction. It's certainly something to consider if you need something better than the 10 centimeters that your current GeoXH is capable of. So the benefits here are pretty obvious. You're still working with a mapping and GIS system, which means you're collecting point features, line features, and polygons. You still have the ability to use the data dictionary, which means you can apply tremendous descriptive data to the features that you're mapping. So it does promote the GIS workflow, but you're getting centimeter level accuracy. So for those folks working in densely populated areas where property values are very high and maybe the features that you're mapping are very close together, this is one way that you can achieve even greater accuracy but stay in the GIS world. The Trimble floodlight technology, of course, we haven't discussed that in this particular webinar, but I probably should sort of remind everyone what floodlight is. Floodlight is a marketing term that Trimble came up with about 20 months ago, and it describes 3 individual characteristics. The first characteristic of floodlight is you do pick up the Russian satellites. Currently, we have, in the U.S., 31 active satellites. The Russians have 24 active satellites for a total of 55 satellites. So this means that we're able to get positions in very obstructed conditions. And in fact, the only place you cannot get a position would be in a cave or probably underwater. So that's good news. The second characteristic of floodlight is that there are algorithms built into the receiver itself that automatically smooth out lines when you're collecting line features, and it smooths out the perimeter around area features when you're collecting them. And you've probably all had the experience sometime in the past where you're collecting a line or an area feature and you've had a lot of spikes and leaps in your data. So instead of seeing a nice smooth line, you see a zigzaggy line. Well, these algorithms that are built into the receiver itself automatically smooth out those lines, which provide better features. The third thing, and I think this is the most important aspect of floodlight, is that there is a built-in electronic barometer in the Geo series that has floodlight. And the barometer, of course, measures barometric pressure. And this allows the unit to create what Trimble calls altitude-constrained positioning. And this is another way to say that instead of getting vertical data that's 2 or 3 times worse than horizontal, which is very typical with GPS positioning in general, you're now able to get the same accuracy vertically that you're getting horizontally. So in other words, this altitude-constrained positioning puts a ceiling and a floor on the variability that that vertical calculation can be within, and it narrows that so that you can actually get, in this particular case, 1 centimeter horizontal and 1.5 centimeters vertical. So it's highly accurate. Also provides, obviously, faster and simpler data collection, and you're used to using TerraSync anyway, so you don't have to learn a new piece of software in order to get this accuracy. So here's kind of where the rubber meets the road. If you take a look at having a centimeter Geo XH6000, if you're using the internal antenna and you're getting a real-time correction signal, or you're post-processing your data, either way, you get about 3 centimeters. And this is a rather ridiculous specification, to be honest, because if you're hand-holding the Geo XH6000, there is no way that you can properly position that antenna over the point that you're attempting to measure. But these are the specifications nonetheless. If you use the tornado antenna, and the tornado antenna is designed for the Geo XH6000, not the Geo XH centimeter edition, you get 2.5 centimeters horizontal, 3 centimeters vertical. So this should really point up to you, this is why you need to have that better antenna called the Zephyr Model 2, because it will in fact produce that 1 centimeter that the handheld is now capable of. So pretty powerful. I've actually done some testing on an NGS control point down here in Oregon, and I actually set up my range pole with a bipod so that the range pole was statically held in place. It was plumbed over the point. I connected to both the Oregon real-time correction system and then later the Washington real-time correction system, and was able to get better than 1 centimeter on this control point. So it's a pretty powerful solution. Okay, here's our second polling question. This second polling question asks a question. It says, obtaining 1 centimeter of accuracy would allow me to do what? Oops, sorry about that. So let me share that poll with you. And when it appears on the screen, just take a couple of seconds and see if any of those answers might apply to your situation. Looks like we have about 80% voted so far. Give it another couple of seconds. Okay, I'm going to close this poll and share it with everyone. You can see the results here in just a few seconds. Looks like 33% say provide a better product for my clients. This typically means you're either in private enterprise, possibly public enterprise, depending on who you work for. Interestingly, we are getting more requests for this kind of a system for those folks who want to provide control for LiDAR projects. We do have some people that are using 10 centimeter data for this, but 1 centimeter data would probably be a little better. We're having this a little more often. GIS, environmental GIS firms are sometimes getting requests to provide better accuracy. You could actually respond to contracts in some cases that are requiring survey grade accuracy depending on the accuracy requirements in the reporting. And some folks say, yeah, all these reasons, and just about 11% say no, none of these reasons would be a good reason to upgrade. Okay, so here are some of the correction options for centimeter accuracy. How do you get this centimeter in the field or post-processed? That's a big question. If you're getting real-time corrections, and this means you're tying either into Wi-Fi, you're tying into a cellular signal to get to the internet, or you're using a local base that is broadcasting radio frequency, any of those can provide you with real-time corrections. Ideally, you want to pick up a base station that's collecting L1, L2, G1, G2. And this means you're getting the maximum amount of data that can apply the corrections to your rover. And of course, that's what you want if possible. The other way is to do exactly the same thing. Use a base station that's fairly close to you. If you're using a single base, you have to be closer than 30 kilometers from the base station to your project site. And the reason you have to be so close, this is about 18 miles or so, the reason you have to be so close is because you're shooting for a centimeter of accuracy. You're no longer accepting sub-foot, sub-meter, or 2 meters. You're trying to narrow it down to a very high degree of accuracy. So the baseline distance, or in other words, that distance between your base station and your project site is very critical because you're adding less error the closer you are to your base station. You can receive real-time correction messages, and when you're using TerraSync Centimeter Edition, you can receive them via these various radio protocols. And these are all just acronyms that describe the transmission protocol of how that signal is being received. But the bottom line is TerraSync can receive RTCM2, RTCM3, or correction measurement records, CMR, CMR+. And almost every base station out there that is broadcasting real-time corrections are using one of these protocols to broadcast their signal. So the thing to take away from that bullet point is simply that TerraSync can pick up the real-time corrections. The other option would be what we're going to discuss in a little bit here, and that's using the Intuicom and the Pacific Crest radio system to get real-time corrections in the field, and we'll talk about that in just a second. So most of you may be familiar with the Geo 6000, just a couple of little bullet points about some of the features that it contains. It does include an integrated 5-megapixel autofocus camera, which allows you to attach a photographic record as an attribute to the features that you're collecting. Obviously, it includes this beautiful 4.2-inch sunlight readable display, and this is proven to be Trimble's best screen ever. So it does look very good under bright sunlight. It looks good under darkness. It even does well under overcast skies. And overcast skies has been the big challenge for screens because of the ambient light and the fact that the light is so diffused that there's not a single light source. So screen does very good under overcast skies as well. So a little bit about the Pacific Crest radio. Pacific Crest is a company that's been around for about 20 years. Several years ago, Trimble purchased this company, so it is now a Trimble-owned company. And they specialize in providing excellent transmission between base stations and rovers. So the Pacific Crest radio is using a low-frequency band between 403 and 473 megahertz. And this is a fairly terrain-following radio wave, which simply means that the radio wave is able to undulate along various terrains and actually successfully get to your rover when you're out there, depending on getting real-time corrections from your base station. So these are some of the specifications of the particular radio. And one of the things to note, I believe, is that it's got an IP address, or an IP rating, I should say, of 67, which means it's impervious to dust and it's actually submersible to a meter underwater. So it's a very rugged radio that can be used in very difficult conditions. Okay, you would typically marry that Pacific Crest radio with what this new product is called the Intuicom RTK Bridge. RTK is simply an acronym that stands for Real-Time Kinematic, and that simply means that you can do surveying on the move. And the way this is set up is that you would set this RTK Bridge, and you're looking at this, this blue box. You're setting up this RTK Bridge somewhere on your project site that can pick up an extremely weak cell signal. And so this does depend on getting some sort of a cell signal somewhere near the project site. It doesn't even have to be on the project site. But if you can pick up a signal that has 1/2 of 1 bar, then the Intuicom Bridge will pick this up and rebroadcast this signal over a radio frequency, which is where the Pacific Crest radio comes in, and it will then send that up to 1,000 feet away from the bridge directly to the PAC Crest radio, which is plugged directly into your Geo 6000. If that's not enough, you can actually use a couple of RTK bridges to sort of leapfrog this super weak cell signal from one to the other that will eventually get to the Pacific Crest radio that is attached to your Geo 6000. So it's basically a way to get some sort of a real-time correction to a fairly remote project site, but it does depend on getting that cell signal from somewhere. We've had customers turn on their RTK Bridge. You can look to see when the signal is available, and they'll end up parking their rig on the top of a hill, which they can pick up this signal from a remote cell tower. They then plug it into the cigarette lighter of their vehicle. They put the broadcast antenna of this bridge on the outside of their vehicle, which then will broadcast that correction signal to the project site. So here's a photograph of a guy using this system. You can see in this particular case, he's got the RTK Bridge mounted on a pole. There's an antenna. One of the antennas is picking up the weak cell signal. The other antenna is rebroadcasting that signal to the Pacific Crest radio. And you can sort of make out the radio attached to the range pole. It's underneath the Geo 6000. So let me give you a slightly closer view of that so you can sort of see what they look like. There's obviously a little stand or a little bracket that will hold the PAC Crest radio on the pole. It's a very small, lightweight radio. You can see that the Geo 6000 is on its own bracket, and then, of course, that's plugged into the antenna, the GPS antenna that's on top of the pole. Okay, so let's ask our last polling question. If you used a 1 centimeter mapping system, or sorry, if I used a 1 centimeter mapping system, I would be able to do what? So take a look at these options and just take a few moments and make your selection. Looks like we have about 80% voting. We'll give it another couple of seconds here. Okay, let me close this poll and I'll share it with everyone so you can see what the results were. Looks like about 10% would rely upon real-time corrections via VRS. So at least some of us live in a state where VRS is available. 5% might rely upon corrections using a single base. 25% on post-process. Now, post-process is the same issue, whether you're receiving real-time signals from a single base or you're using a single base to apply corrections to your data later on. Your base station must still be within 30 kilometers of your project site. so you're still looking at about 18 miles. 35% of you say a couple of those selections, and 25% say they would use all these methods. Yeah, great idea. So let's move on to this. We'll have a couple of more slides, then we'll open this up for questions. Here's the new unit that was just introduced yesterday. I was actually out of the office on the road all day, so I didn't get to see this webinar that Trimble presented. But I got enough information last night to add these couple of slides. It's called the new Trimble Geo 7X. It includes a modular laser rangefinder. So you can see the little black item with the dual objective lenses that's mounted directly under the antenna. The idea was to put the optical center of this laser directly under the phase center of the built-in GPS antenna. And by doing so, this would allow people to collect a position where the antenna was located, take a shot to a feature that might be 100 feet away, and be able to successfully map that feature without having to hold the antenna directly over the feature. This new unit also includes a 3.5 cellular modem. Now, you may remember on the Geo XH6000, the earlier unit, you had to purchase that as an option. This new unit includes the cellular modem that's activated, and the good news, I think, is that it can be activated through a GSM modem, and those companies would be either AT&T or T-Mobile, but you can also activate it using a CDMA modem, which would be Verizon and Sprint. So the modem in this new unit now supports all of the popular carriers in the United States. Instead of having just 2 gigabytes of onboard data storage, it now has 4 gigabytes of onboard data storage. And that's not such a big deal because data storage is relatively inexpensive, and you can always put an SD card inside your Geo to get more storage. But it's nice that they added a little more storage there. I think one of the big deals is that it includes a 1 gigahertz processor. Compare that to the 600 megahertz processor on the Geo 6000, and you're going to be using a operating system and a processor that's much faster. And nobody's going to complain about having a faster computer. And then finally, and I think this is a big deal, you can purchase the Geo X7 as a sub-meter unit. Now, this would be comparable to the Geo 6000 XT. But if you get the Geo X7, you can upgrade it to a decimeter unit, and you can also upgrade it to a centimeter unit. So now, rather than having to decide, do I get an XT or an XH, you now just buy one product, and it can be upgraded infinitely all the way up to the 1 centimeter level. So nobody has this yet. I haven't seen one physically. All we are looking at is just these photographs. They're going to begin shipping the end of November. We should actually have one in our hands sometime during the first week of December. And here's something interesting I calculated last night. If you take a look at the cost of a Geo XH6000 with NEMA output activated and a 3.5 cellular modem that you paid for, this new Geo 7X will cost you $505 more. And so that doesn't seem like a lot of money. But what's interesting is that you're also getting the laser rangefinder, and if you added an external laser rangefinder to your existing Geo 6000, you would have to buy a $1,695 laser with a couple of $100 worth of brackets to attach it to your range pole, which would end up costing you almost $2,000 additional. So this is a pretty dramatic improvement, I think, not just in cost but also in features, where rather than having an external laser rangefinder, if you happen to be using one, you can now have it as part of the GPS unit itself. These units are also on the GSA contract for those who are federal purchasers. They're going to be on the approved equipment list and on the GSA contract, so you can take advantage of those discounts. So give me a moment here so that I can unmute everybody, and then we'll open this up for questions.
Unmuted.
So anybody have any questions on what we presented here? Sorry guys, I'm still trying to unmute everybody. Give me a second. Can you guys take me off speakerphone as well? If you guys can all hear me, please take me off speakerphone if you don't mind. Does anybody have any questions? Okay, guys, I guess there's nothing else. I appreciate your attendance. Let me show you our contact information. You've got my contact information there. My name is Jim Lom with Electronic Data Solutions. We've got folks working out of Missoula, Montana, Jerome, Idaho, Sacramento, California. Please feel free to contact any of us if you have questions about these products, and we'll be more than happy to help you. We appreciate your attendance very much. Thank you very much.